What's up guys, my name is Faisal Al-Edaily and welcome back to another episode of Celestia. Today we're going to be visiting the solar system, so it's going to be like a visitor tour. First we're going to see the star, which we all know it's the sun / soul. So here it is. Let's click on it. And here it is. It's a yellow main sequence star, and you can also see, you can also say that it is a yellow dwarf. Now, its class is a G2. It's a G-type star, which means it's the yellow period, like the yellow temperature, and its temperature is 5700 degrees Kelvin. And if you want to change it to Celsius, if you press Command and then comma, or Control and then comma for Windows users, Microsoft, and then you go to time and region, and then measure units. So we have metric and imperial. I'm just gonna keep it metric. And temperature scale. So we have Kelvin, Celsius, and Fahrenheit. Let's make it Celsius then. So 55 degrees Celsius. And its radius is basically just one sun, almost 700,000 kilometers. Rotation period is 25.4 days, and that's it. Luminosity is just 1 times the sun. Now we have the planets, so planets and moons. So first we have Mercury. It's the first planet to the sun, the closest one I mean. And I like how Mercury looks in Celestia. Here it is. And its radius is 2400 kilometers. Rotation period is 58 days. It's 5.5% the mass of the Earth, and it's 167 degrees Celsius because it's very close to the sun. So next we have Venus, and Mercury doesn't have a moon. Venus also doesn't have a moon. Venus, oh yeah, it's very, like, you can see here it's like a blank just atmosphere, because the clouds, the atmosphere is very thick. It has a lot of atmospheric layers, which also means that it traps more heat. That's why it's 464 degrees Celsius. That's because it's more heat trapped in the atmosphere. It's like they're like absorbing the heat, and then they're never reflecting it. Well, they are, but not most of it. Like just a bit. And the mass, radius, and density is pretty similar to Earth. Speaking of Earth, next planet is Earth. So here it is, Earth. The planet with life and the one that we live on. It's 15 degrees Celsius, and its equatorial radius is 6300 degrees Celsius, and the polar radius is also 6300 degrees Celsius, so it's pretty spherical. And there you can see the Hubble Space Telescope. Here's the Hubble, and there's also the ISS. Here it is. So that's the Earth, and if you didn't know, by the way, it has a moon too. So here it is, the moon. It's 380,000 kilometers away from the Earth, planet, and it's pretty spherical too. It's actually very spherical, and it looks very cool. Rotational period is 27 days, by the way, because it's also tidal locked with Earth too. So next we have Mars. It's the red planet. Here it is. And you can also see like its own north and south pole. There's not that much ice, to be honest, or snow I guess, because there is ice. And you can also see the like spaceships orbiting around it. So we have actually before we go there, I want to show you, here is Valles Marineris, which is the biggest canyon in the solar system. And like around here, right here it is, yeah. That's Olympus Mons right there. Olympus Mons is the largest volcano, or actually the largest mountain in the solar system, which is really cool. But what I was going to say is that we do have the spaceships. So we have the MGS, the Mars Global Surveyor. Here it is. And we have the Mars Odyssey. It also orbits around Mars. They look pretty similar. And this one's like, it has like a long thingy. I like it. And Mars has 2 moons this time. And they're both very small moons. First we have Deimos. Deimos is the further one and the smaller one too. Its radius is 8 kilometers. And Phobos, the closer and bigger one. Here it is. It is 13 kilometers in radius. So that's it for Mars's moons and Mars. So next we have Jupiter. Jupiter is the biggest planet in the solar system. It also has rings. They are very faint rings. You can barely see them. Actually, I don't think you can actually. Yeah, it's very hard to see them. You can't probably see them. So it has 95 moons, and it's also the densest and most massive planet in the solar system. We have Io. Io is the closest moon to it, and it's also the densest and most gravity moon. It is the most volcanic active thing in the solar system because it's super close and big. I think that's why. So here it is. Has a lot of spots. These are volcanoes. And then Io is the closest Galilean moon to Jupiter, and the Galilean moons are the 4 main moons and biggest moons of Jupiter. So next we have Europa, the smallest. This is the smallest one. It's smaller than the moon. Io is basically the same size as the moon. It's a little bigger though. And here is Europa, and it also has these scratches, which are really cool. And it's believed that it has a very big underwater ocean, around 100 kilometers in length. It's below the ice in here, so that's really cool. And there could be life in here, but that's just a theory. And then the next one is Ganymede. This is the biggest moon of Jupiter, and it's also the biggest moon in the solar system. It's 2,600 kilometers in radius, and it has a rotation period of 7 days. So here it is. Looks super cool. Next is the furthest of the Galilean moons, and is also the 3rd largest moon in the solar system, Callisto. One of the most cratered surfaces moons, and here it is. So that's it for the Galilean moons for Jupiter. Next we have Saturn. Saturn is the least dense planet, and it's also the 2nd biggest and the 2nd most massive. It also has these crazy beautiful rings. You can see them. This is the only ring that's actually easily visible, and it also has the most moons out of every single planet. Jupiter has 95. This one has 146. So it has a lot of moons, as you can see. It has 7 major moons. First one is Mimas. It's the closest one, and the smallest one, I guess. Mimas barely has a spherical shape, and it's 207 kilometers in radius. Next is Methone. Now, Methone isn't a major moon, but I wanted to show you because its shape. It's a very cool and unique shape for a moon. It's called Methone, and it's very spheroid. It's a spheroid elliptical shape, which is really cool. And it's very small, though. It's 1.94 times 1.29 times 1.21. That's because it's such a spheroid. This is basically the planet Haumea. Haumea will be in the video, but it's a dwarf planet actually, not planet. It will be in the video though. It is in the solar system. Now next we have Enceladus. Enceladus is actually the brightest moon. It has the lowest magnitude, which is really cool. Here it is. It's also believed that it has an ocean. It's Tethys. Yeah, Tethys is after this. Saturns 5th largest moon. It's the least dense of all the moons in the solar system, by the way. That's just a fun fact about Tethys. And also, its radius is 530 kilometers. Now we have Dione. Here's Dione, 4th largest moon of Jupiter. Next is Rhea. It's also believed that it has an ocean behind its surface. Under its surface, I guess, of ice. Next is Iapetus. People call Iapetus the yin and yang of the moons because half of its surface is dark and half of it is white. Here it is. And you can see here why they call it yin and yang. And next we have Titan. Titan is the largest moon of Jupiter, or Saturn, sorry. the largest moon of Saturn, and it's the second largest in the entire solar system. It is also the only moon that has a stable atmosphere. You can see here, you can see the atmosphere right there. And it also has water on it. It's not H2O though, it's actually methane water. It has methane lakes. It also has a possibility of life. That is also a theory. Next we have Hyperion. Now Hyperion isn't really one of the major moons, but I just wanted to show you guys because of its unique shape. Because it's the largest non-spherical moon. Because when something gets too large, like a moon or asteroid or whatever, blah blah blah, it has to get because of gravity, it will turn into a sphere, always. So this is the largest non-spherical moon in the solar system, not just of Saturn. It is 180 kilometers in radius, and it's not spherical. Next we have Uranus. It has 27 moons, and it also has rings. You can't see them. This time you can see them, but I'm not sure. It's very, very hard to see them. Let's slow things down. And it has 27 moons and 5 major moons. First of the major moons, we have Oberon. Here it is, Oberon. This is the second most large one. This is definitely not what it looks like in real life, but the quality is really bad because we don't know what it actually looks like since it's very far away. And we have Titania, which is the largest one. Here it is. Looks pretty similar to last one. Next we have Umbriel. Umbriel is a little smaller. Here it is. And Ariel. Here is Ariel. This one's my favorite, by the way. And the smallest one out of all of them, Miranda. 235 kilometers in radius almost. So that's it for Uranus and its moons. Next we have Neptune. Neptune is my favorite planet actually. Here it is. It's like a deep blue color. And it also has rings, but you can't see it. Yeah, you can't really see it. It has the largest storm in the solar system. Oh yeah, I forgot to show you. Jupiter has its storm. It's called the Great Red Spot. And Neptune has its own storm, the Great Dark Spot. And it's the biggest storm in the solar system. And it has 13 moons. The biggest one is Triton. Well, there's a theory. Okay, why is it so blurry over here? I'm not sure, but there's a theory that it's not actually a moon, but it was a dwarf planet that got captured by Neptune's orbit, and that's why it's the only one that is actually a big one, because there is Proteus. This is the second largest one. It's 212 kilometers per kilometers in radius. There it is. So that's why Triton, all of these moons are less than 200 kilometers. So that's why there's a theory that Triton, because it's over 1,300 kilometers in radius, so they think it's a captured planet. Or dwarf planet, I guess. Because it is bigger than Pluto too. I think it's a correct theory. Next, we will go to the dwarf planets. So first one, we have Ceres. This is technically an asteroid, but it's also a dwarf planet, but here it is. I mean, the rotation period is only 9 hours, which is kind of cool. Next we have Orcus. Orcus it's in kind of like a binary system with another moon, which is Vanth. Here's Vanth. So if you speed up time, it's basically just like Pluto and Charon. We'll get to those in a bit, but Vanth and Orcus do orbit around each other. If we speed things up, you can see that Orcus is moving and Vanth is also moving. So that's really cool. Orcus is also one of the smallest dwarf planets. It's the second smallest, if not the smallest. I'm not really sure. Let's go to Gong Gong. That's like a tongue twister right there. Let's go to Gong Gong. Let's go to Gong Gong. I'm not sure. It's pretty easy sometimes. So here's Gong Gong, and it also has its moon, which I don't want to pronounce it. I don't know how I will. Xiangliu. I don't know, bro. But here it is. It's orbiting around Gong Gong. There it is. Next we have Makey Makey, or Maki Maki, or Make Make. I don't know how to pronounce these. And it also has its moon. Here it is. Next we have Eris. Eris is the second biggest one. Pluto's the biggest. And it has its moon. Dysnomia. It's a pretty big moon. It's 300 kilometers in radius. Like it. Sedna. And this, what's unique about this dwarf planet, it's the furthest thing in the solar system. So if we zoom out more and more and more and more, here it is. So you can see how it also has like a very elliptical orbit. If we speed things up like 10 billion times, 100 billion times here. It has a very elliptical orbit, and when it's at its perihelion, look at its temperature. It doesn't say it. Let me press V, so then more information. Oh wait, it does say here, negative 265. And when it's its closest point, it's at negative 246. It's still very, very cold. It's one of the coldest things in the solar system, if not the coldest one. And it's also it has a radius of 500 kilometers. Next, we have Varuna. I'm not sure if this is a Kuiper Belt object or a planet, but I just want to show you because this is the most spheroid like planet ever, slash dwarf planet or anything. Look at this. You can see the radii of it. It's 502 kilometers times 301 times 216. That's how elliptical and spheroid it is. And it's also very far away from the sun. Not as far as Sedna, but it's pretty far still. All the dwarf planets are very far, except for Ceres. That's the only one that's kind of pretty close. Next we have Haumea. Here it is. And it also has a very spheroid looking shape. And it has rings too. You can see it. There they are. Haumea and its rings. And it has two planets, Namaka and Heaka. I'm not gonna look at those because I feel like no need to do that. Next we have Pluto. Pluto, this is in 2006. It used to be a planet, but then they made it a dwarf planet. And this is also like Orcus Vance. It's a binary system between Charon. So here's Charon and here's Pluto. And then if you speed things up, whoops, that's not okay. Wait. Yeah, here we go. Okay. So if you speed things up, you can see they are both orbiting around each other. So that's how these binary systems work. And they do have 4 big or small moons orbiting around each other, or orbiting around them. Styx, Nix, Hydra, and Kerberos. And that's it. That's it for the dwarf planets, and that's it for today's video. So if you enjoyed it, feel free to hit that like button and subscribe if you haven't already, and I'll see you guys in the next video. Peace out.